All right, so in this video, we're going to go over the analysis plan for one-way analysis of variance. Here's the summary, but we're going to use our example to go through all the different items in this analysis plan. So recall that our research question was this. Of the four POS display formats, does any one format outperform the other? So step one is to look at whether the analysis variable is interval or ratio. So we're dealing with cells. So that's ratio. And then are the groups mutually exclusive? Yeah, you're either going to be using format A, format B, format C, or format D. So requirements 1 and 2 have been met. And then number 2, step 2, we'll check for outliers in the analysis variable. So we'll use the z-score method to identify outliers. And you would have to calculate the z-score separately for each of the four display formats. And what we have here is the cutoff would be 3.29, the absolute value. So let me make that note here. So anything above or below 3.29, we would consider an outlier, and we had to do that for format A, format B, and then we didn't show format C and D to save space, but we also did that. And there are no values, negative or positive, that are 3.29. So there are no outliers. And if you did find outliers, then you would have to remove that, and that would be something for you to report in your analysis. So that's what this part is. Indicate you delete any outliers and then indicate you did this in the report you write. Step 3, check that the analysis variable is normally distributed in each of the groups. So the usual way to do this would be to look at the histogram, look at the skewness, or QQ plots, but that gets a little cumbersome if you were looking at a lot of groups. So for example, if you were looking at the 50 different states, well, that's just going to be potentially a lot of work. So a better way is to look at the normality of the residuals from the one-way ANOVA analysis. If the residuals are normally distributed, then the normality requirement has been met. Now, here's the thing. We haven't covered residuals in this course yet. We will later, or we might later. For now, just take it by faith that this is what it looks like. So first, a little explanation about residuals. So residuals are the unexplained variance in our analysis. So recall that when we talk about the effect size, we say that this is how much variation in the dependent variable is explained by the independent variable. So in our example, we're saying that the effect size would be how much the format affects the cells. And then if that's how much the format affects the cells, well, then the opposite would be true. Like there's some kind of measure that explains or that covers the unexplained variation. There's something else at play, and that's what the residual is. It's the unexplained variation that our independent variable cannot account for. So there's something else affecting the cells besides just the format of the point of sale display. Each case will have its own residual. So in this case, we had 60 observations. So we are going to have 60 residuals. And we're going to look at the QQ plot to help us determine if we have met this normal distribution. So here's the plot of the 60 different residuals. And in a perfectly normal distribution, all the dots will be on this diagonal line. But in this case, it's not. But it's pretty close to the line. So we would say that it's close enough that we can conclude that the residuals are nearly normal. Now, you might have noticed that I didn't really talk about what standardized residuals mean and then theoretical quantiles, because honestly, we don't really care, right? So we just want to see where the dots lie and then go from there. And as I said, we can conclude that the residuals are nearly normal. It's pretty close. So we'll say that step 3 is good to go. So then we go to step 4. We obtain the output for the analysis and test the equality of variances assumption. So recall that the Levine's test, just like what we did in the t-test, is not going to help us answer our research question. This is just a preliminary test, part of going through our different assumptions and requirements. And this would be the output that we get. We look at the p-value, and when it's large, like this one, greater than our alpha 0.05, then we will not reject our null hypothesis in this case. So not reject the null hypothesis. And when we don't reject the null hypothesis, then yes, we have met the equality or homogeneity of variances requirement. So yes. And then step 5 would be to examine the output and interpret the results, but we'll do that in the next video. And then step 6 and 7, well, as I mentioned, we're not going to do post hoc tests in this class because it gets a little complicated and I don't want to go there unless we have to, because maybe your project this semester requires taking that extra step. All right, in the next video, let's go through step 5.